Alright, so today we're going to look at the numbers practice exercise that was dished out some days back. We will start with the first question. Here is a list of numbers: -7, 0, 2/5, 3, square root of 20, 27, 41, and 49. Now the question asks, from the list, write down the two prime numbers. And we do know that prime number is a number that only has two factors, that is 1 and itself. So clearly we can see that 3 is a prime number because it only has 1 and itself. The next prime number that we get to see here is 41. If you look into your times tables, you will realize that 41 is not a multiple of any particular number besides 1 and 41 itself. So hence we've got 41 there. So the prime numbers that we have are 3 and 41. Now from the list, write down the cube number. Now a cube number is a number obtained when you multiply by a number by itself twice, like when you say 2 times 2 and times 2, you get 8. So in this case, a cube number that we have there is 27, because if you say 3 times 3 times 3, do you see that? 1, 2, 3, you get 27. So indeed, the number that we should be writing here is 27. C, from the list, write down the irrational number. Now, if you go back to the lesson video, you understand what an irrational number is. It's a number that cannot be written as a over b. It's not an integer, and it's a square root of a non-perfect square, or it's the square root of a non-square number. Now 20 is not a square number, but we see a square root there, so you will then select what? 20. Moving on to the next question. Write the smallest prime number. Write the smallest prime number. Obviously, we are no longer working with this list given. We are now on a new first question, number 2. Write down the smallest prime number. Obviously, the smallest prime number is 2, which is also known as a prime even number. Write down a number between 1 and 100 that is both a square number and a cube number. And we do know that if you say 4 times 4, you will get 16. That makes 16 a square number. But if you also say 4 times 4 times 4, you get 64. And hence, this is a cube number. So you get something like that. So what about if we say 8 times 8? What are you going to get? 8 times 8, you will get 64. So you see, so it means that we will rule out 16, and it means that we're going to have 64, which is both a square number and a cube number. Explain why 1 is not a prime number. Remember the definition of a prime number. A prime number is a number that can only be divided by 1 and itself, and therefore 1 only has itself. A prime number is a number that is two factors only. So you could say 1 does not have two factors. Alright, moving on. Write down all the factors of 30. I did show you on the lesson videos how you can write all the factors of a number, especially these numbers which are less than 100, or numbers probably that are even less than 300. They are quite easy to, you can use this method whereby you then decide to say 1 into 30, you get 30. And in the process, you have written the second factor of 30, which is 30 itself. You also try 2 into 30, how many times? You realize that this is 15 times. You try the next number, 3 into 30, how many times? It's 10 times. We try 4, which cannot do. When you try 5 into 30, how many times? 6 times. And you've completely written all the factors of 30. Now, let's move on. Now here we are to list part B here. We are to write down the first 3 multiples of 12. So I believe that you could start with 12 itself. 12 times 1, you get 12. 12 times 2, you get 24. 12 times 3, you get what? 36. There you have it. Write down the largest 2-digit multiple of 9. The largest 2-digit multiple of 9. 2 digits. Obviously, multiples of a number can go up to infinite, but they're saying there is a limit. 2-digit multiple. If you say 9 times 1, you get in 9 digits. If you say 9 times 2, you get 18. But 18 is not the largest 2-digit multiple of 9. But however, you try 9 times 11. What are you going to get? You're going to get 99. The moment you say 9 times 12, you are bound to get 108. So, which is now a 3-digit. So 99 is the largest 2 digits of 9. Now let's move to question 4. Write 180 as a product of its prime factors, giving your answer in index notation. So if you are to write down 180 as a product of its prime factors, hopefully we have enough space here. I will need to get us some space. Okay, so some bit of working. It says write down 180 as a product of its prime factors. So you're going to say 180, and you are going to say 2 into 180. You will get 90. 2 into 90, that's 45. You can no longer use 2. Then next is 3. 3 into 45, you get 15. We still use 3. 3 into 15, that's a 5. We can no longer use 3, but we move on to the next prime factor, which is 5 itself. This is called the prime factorization method. You only use prime numbers, starting with the smallest possible number that can get into this number. And now 5 into 5 is just 1. So as a result, it means that if we are to write 180 as a product of its factors in index notation, first we start by assembling these numbers. 2 times 2 times 3 times 3 and times 5. Guess what? This can now be written as 2 to the power of 2. This can also now be written as 3 to the power of 2. And finally, you have 5 to the power 1, which can be left like that. So hence, 180 as a product of its prime factors, giving the answer in index notation, will be 2 to the power 2, 3 to the power 2, and times 5. So we are going to put that here and then say 2 to the power 2 times 3 to the power 2 times 5. This will get you 4 times 9, which is 36. 36 times 5, which is 180. So that would be your answer. Now we do the same. Write 126 as a product of its prime factors, giving your answer in index notation. So we are going to follow suit with the same method. We are then going to write 126 as a product of its prime factors. And by the way, how do we do it? 126. You then divide 2 into 126. You will get 63. Now, 2 is the smallest prime number, so that's why it's called the prime factorization method. You only use prime numbers, starting with the smallest possible prime number that can get into 126. Then now you can no longer use 2, you now use 3. 3 into 63 is 21. We still use 3. 3 into 21, you get 7. And then now we can no longer use 3. You try to move onto the next prime number, which is 5, of which 5 can't get into 7 without leaving a remainder. Then we have to use 7, the number itself 7. And now this is what we have. So it means that 26 can be written as follows: 2 times 3 to the power 2 times 7. So it means that we can now write 126 as 126. And then you look at this, what you have here. You have 2 times, take note that this is 3 times 3, which can be written as 3 to the power 2 and times 7. And guess what? We then put our answer aside, and then we can say 2 times 3 to the power 2 times 7. Okay, now moving on, we will get to talk about HCF. I believe you recall how we get to find HCF. Now we want to talk about finding the HCF. Now it says or reads, find the highest common factor of 180 and 126. Find the highest common factor of 180 and 126. So I'll put up this for our working. So we're looking at that is 180 and 126. And the good thing is we had earlier written 180, if you observe above, prime factor 180 as a product of its prime factors. We also had written 126 as a product of its prime factors in index notation. So we can use this to our advantage, and we have the following for 180, which is 2 times 2 times, and then 3 times 3 times 5, of course, which is 2 times 2, 3 times 3, and then times 5. Then 126, 2 times, you see 126 is 3 to the power 2, so times 3 times 3 and times 7. So if we're looking for the HCF, we are going to use what is known as the pairing method, so you can get to pair. Now, for example, you've got these two can be represented, this pair of 2's can be represented by 1, 2 over here, but we can no longer pair these 2 with any other 2 beneath, so we skip that one. We move on to 3, which can be paired with the 3 beneath, and when you say times 3, you can clearly see that this 3 can also be paired by this 3. Now 5 no longer has any number, or doesn't have any number to pair it with beneath, and as well as 7 doesn't have any other number above, so hence we leave it at this, and as a result we have 2 times 3, which is 6 times 3, which is 18. Therefore the HCF of 180 and 126 is 18. Okay. Now we get to talk about the lowest common multiple of 180 and 126. So it's the same thing now. We have to then write 180 again, perhaps in that notation, 2 times 2 times 3 times 3 times 5. Then now we have 126, which we have 2 times 3 times 3 times 7. Now, when it comes to LCM, remember that we look at the highest possible power that a number has. For instance, here we have 2, yet we have 2 to the power 2 here. So we are going to take 2 to the power 2, or 2 times 2, and we leave the one with the shorter breadth. Over here, we have 3 to the power 2. We also have 3 to the power 2. Therefore, either we are just going to say the highest notation for 3 is 3 to the power 2. So you can either take 3 times 3 here, or you can either take 3 times 3 there, but only one of them. So hence it's now 3 times 3. What about 5? 5 is the highest power present of 5. So you're going to take 5 as it is. The same applies with 7. 7 is the highest power of 7 available. So you will just take 7 as is. So obviously when you multiply 2 times 2 times 3 times 3 times 5 times 7, you get 4 times 9, which is 36. And then 36 times 5, which is 180. And then 180 times 7 will give you 1260. And that will be the LCM. Okay, let's move on. So you've got your answer here, which would be 1260. Now let's move on to the next question. Now I have 2 lengths of ribbon. One is 84 centimeters long and the other is 160 centimeters long. I cut both the ribbons into pieces of equal length with no ribbon left over. Find the greatest possible length of each piece. So obviously in this case they are asking for HCF. So all you have to do is to look for the HCF of 84 and also the HCF of 60. I mean, first you have to write 84 and 60, in their prime factorization notation, or as products of their prime factorization or prime factors. So 2 into 84, you get 42, and then 2 into 42, you get 21, and then 3 into 21, you will get 7, and then 7 into 7 is 1. So as a result, here we are going to have something like 2 times 2 times 3 times 7. So for 84, we will get something like this, which is going to be 2 times 2 times 3 times 7. Then for 60, you are going to also say 2 into 60, you will get 30, and then 2 into 30, you will get 15. You use 3 into 15, which is 5, and then 5 into 5, 1. So let's have a look. It means that we are having 2 times 2 times 3 times 5. So this will be 2 times 2 times 3 times 5. And now we're looking for HCF. So we're going to do the pairing, which is going to be 2 there, therefore saying 2 times, then you can have another 2 there, 2, then what do you have here? Times 3, and as a result, 4 times 3 is 12. So the greatest possible length of each piece will be 12 centimeters long. Using this length, find the total number of pieces obtained. So it means that you will have to then divide, perhaps find the total number of pieces obtained. So one is 84 centimeters long, and the other is 60 centimeters long. So it means you're going to say 60 divided by 12, which will get you 60 divided by 12, get you 5 pieces. Then you're also going to cut this. You're going to say 84 divided by 12, you're going to get 7. Therefore, 5 plus 7 equal to 12 pieces obtained. All right, let's move on to question 7. Question 7, there it is, over here. 2 bells ring at regular intervals. The first bell rings every 12 minutes and the second bell rings every 8 minutes. Both bells ring together at 8 a.m. Find the shortest time in minutes until the bells ring together. So in this case now we are looking for the lowest common multiple, because we're looking at bells ringing at multiple intervals. You see, every 12 minutes, every 18 minutes. This talks of multiple intervals that the bell rings within the hour and probably during the day. So it means that you're looking for LCM. So it means that we have to look for the lowest common multiple of 12, and we also have to look for the lowest common multiple of 18. So in order to do this, to get the lowest common multiple of 12 and to get the lowest common multiple of 18, you can just do this. You can either use the prime factorization method or the conventional method, but clearly we can see that you can either do this 12, and then you've got 24, then you've got 36, then you've got something like 48, and so on. Here you can also say 18, 36, and then now you've got 54, and so on, if you don't want to use the prime factorization method, since these numbers are just small. So as a result, you can clearly see that 36 is the lowest common multiple, and it says that find the shortest time in minutes until the bells ring next together. So the shortest time will be 18 minutes. Okay, then it says write down the next time at which the bells ring together. So as a result, you see that both bells ring together at 800 hours. So it means that the next time that they get to ring together is 18 minutes after 800 hours. So it's going to be 18 past 8. That will be the next possible time. Or in fact, it's supposed to be 36 minutes. My apologies. And therefore, the next possible time until which the bells ring together will be 8:36. 8:36. Okay. Now, moving on, we've got these questions that we need to look into. Now, it then says state whether each of the following is rational or irrational. So as a result, remember how we define rational numbers? Rational numbers are square roots of perfect squares. So you will have something like The root of 36 will give you 6, which is an integer. So this is a rational number. Obviously, a root of non-square number will give you a very long answer. So this is an irrational number. Then this will still be pi is an irrational number, even if you divide an irrational number by 2. So as a result, this will still be an irrational number. Okay, moving on to the next session. Now, write 0,735 as a fraction in its lowest terms. Explain why 0,375 is a rational number. So when you're writing these decimals, look, this is a tenth, a hundredth, a thousandth. So you're going to write 375 over 1,000. And maybe we can try divide this by 25. 25 into 37 is 1. And you'll be left with the 12 there. And 25 into 125 is 15. Then 25 into 100 is 4. And then 15 over 40. We can divide this further by 5. 5 into 15 is 3. 5 into 40 is 8. So the answer here is 3 over 8. Then the question reads, write down two irrational numbers whose product is a rational number. Write down two irrational numbers whose product is a rational number. So you can think of any two irrational numbers and think of a non-squares, perfect square roots of non-squares. So in this case, you can think of like, for instance, if you say square root of 8 times, maybe thinking of surds, then you can even say square root of maybe if you want, you can even say square root of 32. Now what's going to happen now is think of two numbers in here, a square number that can give you 8 when multiplied. So I think you can think of 4 times 2. Then in here, you can also think of maybe you can have something like that will give you, you can even say 16 times 2. And because of that, square root of 4 will become 2 outside the root sign, 2 root 2, then times square root of 16 will become 4 outside. And because of that, now you have terms of root 2. And when you multiply, you're going to have 8. 4 times 2 will give you 8. Then root 2 and root 2 will just give you a 2. And hence the answer will be 16. And there is your answer. Now, let's have a look at number 10. Maybe we can conclude with just a few. Write down the reciprocal of each number. Write down the reciprocal of each number, giving the answer as a fraction in its lowest terms. So the reciprocal of a number is 1 over that number. So this is 1 over 8. The reciprocal of a fraction, you invert, which makes life easy, 5 over 3. Reciprocal of 0,25, you write this as a fraction. If you want, you can say 0,25 is 25 over 100, which is 1/4. And you know what? You invert the reciprocal of a fraction to give you 4. Reciprocal of 1 2/3, you are then going to convert this first to an improper fraction, which is going to be 3, and then 3 plus 2, which is going to be 5 over 3. And then when you invert, this will give you 3 over 5. And that's how you address those questions. Now, the reciprocal of a number k is 0,2. Find the value of k. So all you have to do is to then invert this. So the reciprocal of a number k is 0,2. You express 0,2 as a fraction, which is 1 over 5. Because 0,2 will be 2 over 10, and then simplify, you get 1 over 5. Therefore, you then do this. Therefore, the number k is 5. Now, it then says, work out 2/3 times the reciprocal of 4 over 9, giving your answer as a fraction in its lowest terms. So 2/3 times the reciprocal of 4 over 9 would be times 9 over 4. And because of that, you can now say 3 there, 1, 3 there, 3, and then this there, 1, this there, 2. And because of that, now you end up having the answer 1 times 3 is 3, and then it's just 2 times 1 over there, which is just 2. So the answer as a fraction in its lowest terms will now be maybe 1 and 1/2, or you can leave it like that. Now finally, to the end of the exercise. To the very end of this exercise, let's see what we can get to do. Work out the value of each of the following. So obviously, 2 to the power 5, you are saying 2 times 2 times 2 times 2 times 2. This will give you 4, 8, 16, and now 32. Cube root of 216. That sounds like a 6 to me, because if you say 6 times 6, you get 36. 36 times 6, you get 216. So hence cube root there will be 6. Over here, square root of 111. It means that square root of 121 will be 11 minus cube root of 27, which will be 3, and hence the answer will be 8. Over here, you need to know how to use order of operations, and we start obviously with multiplication, and as a result we are saying 5 plus 3 times 2 to the power 2. We prioritize multiplication ahead of addition and subtraction. Remember BODMAS. You prioritize multiplication ahead of addition or subtraction. So where there is a multiplication sign, on either side you put brackets like this, and as a result this will be 5 plus, now 3 times 2 to the power 2 will be 12, and now your answer here will be 17. And we conclude to the very end of this session.